first thing you're going to want to do is click on the Earth menu and then click on temperature, or temp is where it's going to be. And then you'll have, what that'll do is it'll pop up a map of winds and temperatures. So, so now what you notice is, so in the tropical latitudes, generally everything's pretty warm except in the mountainous areas. But as you move further poleward, what you start to notice is that, yeah, it definitely gets colder, but it doesn't get colder the same rate everywhere. So, for example, right now, the just like we're talking about currents, this part of the Atlantic Ocean is substantially warmer than a much more equatorward part of the Atlantic right over here. And that Ireland is quite a bit warmer than most of Virginia presently, despite the fact that Ireland is probably almost 20 degrees closer to the North Pole than most of Virginia. And so what you notice also is that there's also a very sharp boundary right here. So we have very warm. So what you want to look for is, one, in the mid latitudes, like just looking at the US, look for very sharp boundaries in temperature and wind direction. And that is going to be your front. And if there's bluer air, if there's greenish blue air behind it, that almost, like this, and you have a and the boundary's very sharp, you're almost definitely looking at a cold front. So I'll draw a little annotation on it here. So yeah, right here, you're almost definitely looking at right where these winds change direction, you're almost definitely looking at a cold front. And if there's a weather map, it would look like so.
I'm so annoyed there is a quiz for the breeding. I didn't even think of that. I was like, oh, I'll just read it by the time the book's supposed to be done. And I'm like, oh yeah, shit, we're supposed to be at certain points for quizzes. Oh well.
Yeah, I've been a little bit behind on playing the quizzes. The whole online conversion has been like, thrown a monkey wrench in everything I do. And what I'm probably going to do is make exam 3 well, it's going to have to be take home, and I'm probably going to do some sort of version of it. I'll probably make it take home. I liked what I did for the online version of exam 2 because we had about 4 students who had compelling reasons to not be in class when everything went they're on the exam day. So what I did with exam 2 for those students is I gave them basically the same version, but what you'll probably do is, like, basically you'll still be answering the questions online, but you'll be able to, like, look at it ahead of time and even ask me questions. And definitely, I have a friend who I'm going to hire to proofread it so we don't have as many spelling errors or, like, missing questions, because, yeah, one, a friend could certainly use more good work, and two, you guys could use better more clearly written tests. So yes, that's my commitment to y'all.
Cool.
That's what frontal boundaries look like. In fact, you can also see there's kind of another little front sweeping across the Atlantic right here. Other things to look for are things like counterclockwise swirling of air in the northern hemisphere or clockwise air in the southern hemisphere. That'll tell you have low pressure and wet weather. That'll be a dead giveaway. Whereas this clockwise air, I guarantee you, this is probably fairly calm, clear weather right here, where you have and this is probably high pressure. So notice I'm drawing L's in the middle of all the places that are swirling counterclockwise, and highs over all the places we have clockwise motion. Oh, here we go. We got a nice big high over Texas. Oh, those springtime high pressure cells over Texas are beautiful. Beautiful times to go hiking. Yeah, we got a nice little Rocky Mountain high in the yeah. And so hurricanes. Let's see if we can spot some hurricanes. Hurricanes. We might not have any hurricanes presently because this is not the best time of year to get hurricanes. There was a decent one in the Pacific Basin, which technically makes it a typhoon or a cyclone if it's in the Indian Ocean basin, but no, we don't have one now. We had one about a week ago. Let's see if I can find it. Oh, there we go. Yep. So right now we're in the southern hemisphere hurricane season. Their hurricane season is generally going to be in our spring, their fall. Yeah. So does everyone see the hurricane right here? Well, if you're having trouble spotting hurricanes, again, aren't always hurricanes in our oceans, but but here we go. We got a nice little hurricane here. And so what you can do is once you've located the hurricane, you can then switch on ocean and SST. It's right where all that wind was churning up. Oh, here, and I like to do currents. Yeah, right where we have all those strong winds, you are getting extremely warm water, ocean water. And so I'm hoping what you do is that you sort of are able to play around with this menu a little bit and make sure and get used to seeing animations and color maps. And hopefully if you want to spot a hurricane, you can notice that generally these are powered by transferring heat from the ocean surface to the top of the atmosphere. And if you can't find a hurricane, there might not be in it. The oceans have been a little bit on the quiet side lately, and there are times of year, especially midwinter, northern hemisphere, where we just do not see a lot of hurricanes. I'm going to go back to air. Make sure that you're on air mode for the wind belts. And so what you want to do, again, so because of frontal boundaries, high pressure systems, low pressure systems, seasons, and all that, the wind belts might be a little bit trickier spot. Can you at least spot where the trade winds are? This in here. So what you sort of look for is place. So what you're going to want to do is one, go into. So you're going to want to go into gotbooks.maricosta and then let's see, atmosphere process. Boom. There we are. So this diagram kind of tells you the general directions of surface winds to look for. This is kind of your idealized model. But then if you look at the telescope model, you definitely see winds blowing from polar to east to equatorward west here. You definitely see winds kind of moving like this in the tropics. And you definitely see this in the southern hemisphere as well. But then you have this sort of zone where you typically have clockwise winds in the northern hemisphere, counterclockwise winds in the southern hemisphere. This is your subtropical high. Then you have, notice how you have quite a bit of winds coming out of the west. So this will be your trade winds out here. I really should use the typewriter function, not try to draw this with the pen, but then your westerlies are going to be just north of this zone and often between the trade winds and the westerlies, there's a zone where it's going to look a little bit calmer. So you can definitely see that somewhat here as well, this sort of zone of calm wind patterns. Then you have your westerlies. You notice the westerlies, it's not quite as pronounced initially. It sort of looks all spirally and weird. But you definitely notice that there's more winds blowing from west to east in this zone than there are from east to west. And so I guess what you want to do is sort of compare the pattern of winds that you see at any point on this globe with this model for the world that you see in your textbook. That's my goal. And try to note things that are qualitative, quantitative, and also try to see if you can spot any place where there's wind coming out of the east. Right now we have a very strong low pressure over the North Pole, so we're not really seeing decent east. The only place we see easterlies is not seeing them anywhere just about, but yep. Is basically right north of Scandinavia and Nova Somalia on the north coast of Europe. Yeah, just north of Scandinavia. I see a little bit of flow from east to west. But I bet you if you go down, oh wow. I bet you if you go down towards the South Pole, you'll see stronger flow. Yeah, here we go. Here's some very strong easterly flow. So you want to basically qualitatively compare the direction that wind is moving on this simulation of the Earth versus what you're seeing in your text diagram, and kind of get a sense of what, yeah, basically it's sort of the basic point of the exercise is one, to get